Hey, welcome to part 4. I'm accompanied in this part by Ari doing his improvisational piano in the background. He's really quite good. I'm going to go back to Byne, B-Y-N-E, in 2006. So, he'd shown that the likelihood of rejecting female assignment had to do with how long the baby had had testicular tissue. It was very interesting. He goes on to say, the data do not justify the conclusion that prenatal androgen exposure produces a brain that is hardwired for male gender identity at birth. So, again, we've shown gender behavior, we've shown sexual orientation, both coming from androgens, but gender identity, no. It's just not been shown. Instead, an effect of prenatal androgens may be reinforced by elevated androgen secretion that occurs in the neonatal period and again at puberty. Yeah, whatever. I'm not even going to try to get that. He also, so his final conclusion is that he cautions that psychological, social, and cultural factors might act as co-mediators of gender development. So, again, this subconscious sex that Serrano is basing her work on it's not there. It hasn't been shown by the experimentation, and reading this, I don't think it will be shown. What we have is gendered behaviors which feed into a complex social system to create a gender, and so in this sense, genderqueer is correct in that it's not a biological phenomenon, so it's not a binary phenomenon. It's related to male, female, masculine, feminine binaries, but it's not the same thing. Okay, now I'm going to go on to the animal research, which is really quite bizarre. So it's kind of enjoyable in its bizarre way, the poor animals. But okay, the first piece is Roger Short from 1979. Short castrated male red deer calves within a week of birth and followed their development in their natural habitat. Red deer males, when castrated, do not develop any of the typical male secondary sex characteristics, such as antlers or neck mane, and develop looking like females. Other red deer, males or females, then subsequently interacted with these castrated males as if they were females. They were gathered as hens, I guess that's a female deer, when the stags accumulated a harem during the rutting season. Any intact male would have been driven out. Significantly, this is where it gets weird, these castrated males, seemingly accepted as females by all the other animals with which they were in contact, attempted to copulate as males and showed typical male flamen displays and mounting. Thus, despite looking like females, being considered as females by all the other animals with which they were associated, they displayed male behaviors when the rutting season arrived. To quote Short, surely a most dramatic example of long-lasting imprinting effect of male sex hormones on the brain during fetal life. So basically, they were androgenized early on in fetal development and not afterwards because they were castrated. Of course, we have to look at how long it took to castrate them because of Byne's research. But still, that's pretty interesting. Diamond says this might be seen as an animal model of identity development, but I think he's jumping to conclusions because we're talking about behavior and not identity here. The second experiment is that of Goy, G-O-Y, and colleagues, Goy et al., 1988. These investigators used rhesus macaques, showed that dependent upon the amount, period, and duration of testosterone administration during pregnancy, so they varied that. During pregnancy, they added androgens to female embryos. So depending on the amount, period, and duration of testosterone administration during pregnancy, the effect on the female offspring could be significantly manipulated towards different male-like sexual and reproductive behaviors. So, but regardless of how these behaviors were altered, the genitals might or might not be masculinized. This too can be taken as an animal model of human occurrences. In other words, these two experiments demonstrate that central nervous system differences can be prenatally organized, and these can be more sensitive than those manifest by somatic changes. Yeah, that's definitely interesting, because it shows that you can make an animal gay, you can make an animal into a lesbian by increasing the androgens. And you can also get the sex behaviors by increasing androgens, and that it might take more androgens to actually push the body over. So it's easier to cross-gender the gender behavior or the sexual orientation than to cross-gender somatically. Okay, well, that's interesting. Let's call that a wrap for part 4. Thanks again.